Hello, all of you. I'm sure you guys would have all geared up for taking another session on LR and DI. And the last time also you guys have gone through a few questions. We didn't take too many questions last time, but I think in the questions what we were essentially trying to do, I'm just running down through the questions that we did, right? Just to refresh your memory on the questions. We did some basic questions. This question was an interesting question. It had the sliding rule. This is something we'll repeat in our questions, right? Though it's a question on series, it's used in a lot of other places. Sliding rule we have done a simple questions on series, of course, right? And we did this question on puzzles, right? And with the primary idea, we did this particular caselet. Again with the primary idea, right, where we had to identify the primary idea in these questions. And finally, we left with a question on binary logic, right? So this was a caselet on binary logic. This is two questions on binary logic. So there's something that I want to give an introduction on binary logic before starting. When we are talking of binary here means two, right? Because the next question is again going to be on binary. So binary means there are going to be two outputs. It could be a true, false. It could be a yes, no. It could be a living and dead. What else, right? What else? Maybe getting through a job interview or not getting a job, right? It could be the question of passing or failing, right? All these are examples of binary logic. However, when we're talking of a cricket match, right, now it's no more binary. There could be multiple outcomes. One, there is win, one is loss, one is draw, one there is tie. Now this is no more binary, right? Because there are several results. But if you're talking of, sport like combat sports, there are only two outcomes, right? Two being, win and lose. So all this would be examples of binary, but the more popular one would be the true or false, the yes and no, right? So we had done a question on that, but less on binary, but more on other concepts. A critical reasoning element here we had added. But today's session we'll do on a elementary binary logic, and like I said, subsequently we'll take it a notch higher as we keep progressing with our classes, right? So I hope all of you are ready. All of you, are you ready? Right? Good. Please give a thumbs up or say okay. We'll all start with the class with today's session. This is we have a big thing to do today. We have a lot of PPTs a lot of slides to go through, a lot of questions to discuss. So we'll start with the first question, right? Very simple one. Again, idea is just to map binary logic, right? So let's read the question. I'm giving you about 10 to 15, let's say about 30 seconds to read, and then we'll evaluate the question. Read the keywords. Okay, so I guess by now you would have read the question. Very simple. Anyone with the answer? Who killed Rocks? How many say Ajit killed him? Right? Some of you say Robert. Does anyone say Peter? And what about Mike? Let's see. Let's see what the answer is. This is, like I said, way too simple a question to start. But this is where we want to make a beginning, and this looks like a good beginning. So the question goes like this: Detective Sherlock Holmes finds Rocks lying dead at the bottom of a cliff. So I'm guessing someone would have pushed him off from the cliff. He's trying to solve the case. Holmes is sure that one among Ajit, Robert, Peter, and Mike murdered him, and one among them was a murderer's accomplice. There's someone who is murdered Rocks and someone who is helped murder Rocks. That means an accomplice would normally be with the murderer, right? He questions them. That means Sholmes questions these guys who have the strange habit of either only speaking the truth or only lying. What does it mean? Only speaking the truth or only lying? you'll notice that each of them have made two statements, right? This is statement part 1, this is part 2. That means there are two statements, 1, 2, right? So one of them will be an honest statement or a true statement, and one of them will be a lie. Just understand that. Everybody has made two statements, you'll notice, right? Now, when we're discussing questions like this, like a simple one, we want to make a truth table, right? There's something most of you would have learned in your, while you would have solved logic gates, right? You'd have solved logic gates where you used exclusive OR gates, NAND gate, NOR gate, AND gate, right? So we're talking of the XOR type of gates, right? Where we'll fit in the values, right? Yes, no, true, false, and try to verify whether the caselet is right or wrong, right? So based on that, we'll try to do this question. It might take some time, but there's a foolproof method. 100% you're going to get answers to questions solved by binary logic. It cannot go wrong. That's the idea behind binary logic. That's the idea behind you even trying to attempt these questions if it ever comes in the examination, right? So let's look at two types of statement now. One is an affirmative statement. An affirmative statement, right? It gives us quality. It gives us an affirmation or the positivity in quality, and a negative statement. It gives us what the quality is not about. For example, if you take Mike killed him, it's giving an affirmation on the quality. That means the murderer's name is Mike and Peter was the accomplice. If I check this statement, we get complete information or at least partial information. This is called an affirmative statement, right? However, there's a negative statement as well. For example, if I take Peter, what Peter says Robert neither killed him nor helped in killing him. What is the meaning of this statement? That means we know the murderer's name is not Robert, the accomplice's name is not Robert, but the murderer's name could be three others, including Peter himself, right? And likewise, the second statement of Robert is also a negative statement, right? So both of this would feature to be a negative statement. Now, when we are talking of questions like this on binary logic, we would want to start with positive statement. That means either we start with what Mike says or we start with what Robert says. We generally would avoid the statements which Peter or Mike says because it's not giving us too much of an information, right? Question is easy. Let's start. So we'll make an assumption, right? There's Ajit, there is Robert, there is Peter, and there is Mike. And we'll make an assumption that one among them is speaking the truth and one statement, right? And the second statement, the other person may be speaking the lie in both the statements, and so on and so forth. To start with, we'll make an assumption. So let me put a star mark because it's an assumption, right? What is the assumption? That Ajit is speaking the truth. We normally make a truthful assumption, and both the statements have to be true. That means the first statement is true, and the second statement is also true. Let's see what happens. What does Ajit say? Ajit says Mike killed him. So let's put it here. Mike is a murderer. Let's circle it. And Peter was an accomplice. Let's put a box. So we have the murderer here. We have the accomplice here. This is the gospel truth for us. We cannot change it. Come what may, this is what we have identified with the caselet. From now on, we'll just try to verify whether everything is working or not working. That's it we are supposed to do now. Let's look at what Robert says. Robert says Ajit killed him. Is that true? No, the murderer is Mike and the accomplice is Peter. So Ajit did not kill him. That means Robert's first statement is false. The second statement, what Robert says is Mike was the accomplice. Now, what do you think? Right? Is it true or false? Just by looking at these two cases, right? Was Mike really the accomplice? No, Mike was a murderer. We identified the circle with the murderer. We identified the box with the accomplice. So the first statement is false, and the second statement is also false. That's good news for us because they have the strange habit of either only lying or only speaking the truth. Right? Are we still going good? Are we going strong on this? Superb. Let's look at Peter now. Robert neither killed him nor helped in killing him. Peter says Robert neither killed him nor helped in killing him. Right? Did Robert kill him? No. Did Robert help in killing him? No. Robert's name is not there among these two names. What we had assumed based on the conclusion that we made. That means this first statement is false. This first statement is true because Robert neither killed him nor helped in killing him. That statement is true. So let's look at the second statement here. I neither killed him nor helped in killing him. Did Peter actually kill rocks or help in killing rocks? Yes, he did. Peter was an accomplice as per what Ajit had said. That means the second statement is false. The entire validity of this case is lost. So we cannot use the case again. We are not able to use this case because we have case where we have true and a false. We need either only speaking the truth or only lying. So this is not valid. This entire case is negated. Let's look at the second one. Okay, so we have assumed initially that Ajit is speaking the truth. Why not let Robert speak the truth? Let's see if Robert speaks the truth. That means both the statements of Robert is truthful, right? We have a star mark to show that that is what my assumption is. The assumption we normally make as a truth. We generally don't make a false as an assumption, right? So as per this assumption, as per the assumption, what Robert is saying, the truth that Ajit killed him. So the murderer is Ajit and Mike was his accomplice. That means accomplice is Mike. I've put a circle and a box to identify with the murderer as well as accomplice. Pretty cool, pretty neat. Now let's look at every other statement. Ajit says Mike killed him. Is it true? Mike killed him. The murderer is whom? Ajit, and the accomplice is Mike. So Mike did not kill him. That is false. Second statement. Peter was his accomplice. Second statement for Ajit. Okay, was Peter really the accomplice? Right? Was Peter really the accomplice? Right? No, that is also false. That means we have a false and false. We are going strong. Here it was anyway the assumption, but here we're going strong. Right? We need a true or we need a false. Right? So let's go to the third statement. Peter says Robert neither killed him nor helped in killing him. Did Robert really kill or helped in killing him? No, he did not kill him nor helped in killing him. That is true because Peter is not there among Ajit and Mike. And I neither killed him nor helped in killing him. That's also true. Both the statements are true. Again, superb thing for us because we have already got three of the cases when we have both of them, both the statements of each of them being either only speaking the truth or only lying. The last statement that for Mike, the last person, the two statements, Robert is lying. Now that was the truth. No, we have made an assumption that Robert is speaking the truth. This was an assumption, right? This was an assumption that Robert is speaking the truth, right? So how can you say this was an assumption that Robert is speaking the truth? So what does Mike say? Mike says Robert is lying. Right? That's not possible, right? That has to be a false statement. That cannot be true. And I was with Peter all through the time in question. Right? He was with Peter. Mike says he was with Peter all through the time with question, but Mike is accomplice. Who was he with? He was with Ajit all through the time in question during the murder, not with Peter. That means this statement is also false. So you'll notice that we have a false, we have a true, that is the assumption, right? We have a true, and a false. So that works true. We have the strange habit of either only lying or only speaking the truth. Using that, we can simply identify who killed Rocks. It's pretty simple. This case is negated. This case is absolutely right. The murderer's name is Ajit. And if they had further asked who is accomplice, there would have been Mike. Right? Easy one. I'm sure most of you would have solved it mentally. Right? But this is one of the methods that you could probably use in binary logic, provided it becomes more tougher. Right? We'll do a caselet in the future, which will have each person giving three statements and alternating between truth and lie. We'll make that as part of our questions as well, right? Just give it some time, right? Let this idea, right, marinate in your mind, and we'll probably cook it up later, right? So that's cool. Shall we go to the next question? I'm sure you guys are all okay with this, right? We'll move on to the next question. It's of a slightly different type from what we've done from binary logic. We go to the first time that we are talking of a basic or a general data arrangement type of question, right? Why am I saying general data type question? This is a very popular type of question that comes in the examination. And you'll see a lot of questions on this type has come not only in CAT but ZAT. It's hugely popular. data arrangement question, right? Now, off late, if you notice that cat has started giving something called a, you know, short answer type question, right? The short answer, right? The short answer type question. Now in data arrangement, that could be a new addition which can make it pretty confusing, right? Pretty thoughtful of how to solve it. Then just using the answer options may not help, right? Only answer options, right, may not help. When may it not help? It may not help if we are having short answer type questions. So probably we might have to end up solving the entire caselet, right? That's the new thing about data arrangement, and we'll have to watch out. We'll have to watch out whenever we're doing data arrangement type questions. So very simple one. Again, let's say I give you about 30 seconds, right? 30 seconds to sort it out, and then we'll start with the questions. Please read it carefully, right? About data of 4 people. Let's see what we would want to do. So your time is already ticking. Okay, let's give you another 10 seconds maybe. Is that fine? Okay, so that more or less ends the time. Okay, let's look at this caselet. Let's identify with this. Now, there are several methods in which you can do a data arrangement. Probably in the next sheet, right, we'll identify with another method, but today we'll use the tabular method, right? We'll use that. That's a simple one. We'll put everything in a table, right, and identify it with columns in the table and make rows for a particular set. For example, we can put husband names here, we could put wife names here, we could put children here, and order of arrival. But the question being simple, right? What is the pivotal column? That means what is the main column here, right? What is the main column that you're going to fit into this table? That's really important when you're talking. That's really important when you're talking of these kind of questions. In case you're doing a table, right? It's important that you identify with that. Once you've identified with that, rest of the question will become easy. The pivotal column is critical here in solving it quicker. It's critical here in solving it quicker. So what's a critical thing? What do we put in? Do we put in the name of husbands? Yeah, right. I'm sure all the feminists will hate us for this. Husbands. So what do we put? Do we put the wife names, right? The spouse names, right? Or do we put children? Do we put children here? Right? Children are the future of our country, right? So do we put in children there or something else, right? That's a question that you'll have to ask yourself. But based on what? Based on what are you going to figure out the answer to what should be the pivotal element in this particular case? You read the statement. Let's read the statements together. Therefore, husband name, therefore, wife names. The number of children is no child, one daughter, and one son, and the fourth couple has 2 daughters and a son. So is number of children is either 0, 1, 2, or 3. There are 4 cases, right? 4 cases. And additional information is given, right? Additional information is given on all of this. That's fine. That's all going good, right? But let's read the clues for a while. Shobha arrived last, right? Sonal has only one child. Ashish does not have any child. Avinash is not the last person to arrive. Amit does not have any son. The couple which has only daughter arrived second. And Akshay is not married to Shobha. You'll notice if you're talking of the name of husbands, right? It is there in more number of clues. You will notice that the number of children, right, is noticed in more number of clues than the name of wife. Then the order of arrival, which means the pivotal column, the one that we are harping on, this is important. The pivotal column should either be husband names or the number of children, right? So in this case, to make life easy, what I'll do is we'll put in, right, the husband names as the pivotal column. Now, why this and why not put wife name? I'll just explain to you in a while. Then I'm putting husband names. That's the pivotal column. Everything will be based on it. I will put order here, right? We'll put the wife names or the spouse, their respective spouse's name, and the number of children, right? So we'll start with the name of the husband. Let's just fit that. Ashish, we have Akshay, we have Amit, and we have common names, huh? Most of you. Let's look at the data now, right? So Shobha arrived last. You'll notice that this data cannot be fit in this table. That's a bad part of having this table, right? The wife, right, whose name is Shobha, she arrived fourth. We have not fit it into the table. How sad, na? To start with. Sonal, this person has only one child, right? The one child. We have like the number of children of the three couple, no child, that means 0. One daughter, right? We have one daughter and one son, that means 2 children. We'll have one daughter and one son. And the fourth couple have 3 children, namely 2 daughters and 1 son. So we have 0, 1, 2, 3, right? We have 0, 1, 2, 3 cases. So that means 4 things, and one of the family do not have any child. So Sonal has only one child, that has to be a daughter for sure. Sonal has only one child, that has to be a daughter. Ashish does not have any child. So till now we are only fitting data outside the table. For the first time we start fitting data into the table. Ashish does not have any child. So number of children is 0, can we say? If that is true, that means Ashish's wife's name cannot be Sonal, right? That's another easy case. That means Sonal name cannot be Ashish. Already we have written that. That's something we could fit in our table. Amit does not have any son. See, Amit does not have any son and Ashish does not have any children. Is it possible that both have 0? Not possible, because we have 4 cases, right? So Amit does not have any son. That simply means Amit should have a daughter. There's no possibility of having 0 children because these are all distinct. Everyone has distinct number of likes and dislikes, right? So we'll go in pretty simple. We'll now try to fit in Sonal here because Sonal also has one daughter. Amit also has one daughter. You'll notice these two are matching. So since those two are matching, we can simply assign the values, right? As I take this and place it here, that would be Sonal. Amit and Sonal is a couple. They have only one daughter, which means Sonal cannot fit in anywhere else. That's a good part about a positive statement normally in any of these cases. Further, they say the couple which has only daughter arrived second, and we understood by now there is one possibility, no children, only daughter. This one case has one daughter and one son, and the last case has 2 daughters and 1 son. So only daughter, that means definitely this case. The couple which has only daughter arrived second, so the order of arrival of Amit and Sonal has to be second. Right? That makes life easy. And Akshay is not married to Shobha. Last statement. In any case, Akshay cannot marry Sonal because Amit is already married to Sonal, or Sonal is already married to Amit, right? So we need to place this person. Her name is Shobha. She is still there. Shobha arrived 4th. Can we place Shobha here? Can we place Shobha here? No, we cannot place Shobha here. Why can't we place Shobha here? For the simple reason that Shobha arrived 4th and Avinash did not arrive 4th. Avinash did not arrive 4th. That means Shobha is definitely not married to Avinash, right? Shobha is not married to Amit because Amit is happily married to Sonal. Shobha cannot be married to Akshay because Akshay cannot marry Shobha. Akshay is not married to Shobha, and in any case, we cannot put Shobha with Avinash, Amit, Akshay, which simply means Shobha has to get married to, or Shobha was married to Ashish, right? And Shobha was definitely married to Ashish, and Shobha's order of arrival that we know is fourth. That's the only data we could fit in. The rest, nothing more we can do here, right? So pretty simple two questions. I'm hoping that you guys were able to do. Let's quickly summarize. So we know we put in the names of husband here. That is a pivotal column. Why pivotal? Because in the clues, maximum number of times it is written. Number of children also could be the pivotal column, but I chose husband names, right? And then we started fitting in the data. We saw that these two additional data was outside the table. Now the choice of this method of putting husband names as the pivotal column is so that the number of clues that you write outside the table becomes less, right? It becomes less outside the table, right? While inside the table data gets more. It's not that it's going to make much of a difference, but trust me that few seconds here and there can make a huge difference for you in the exam. Like I say, if you're with me, right, for the next few days, you'll notice the way we start treating LR and DI. In fact, we don't treat LR DI, we make sure we make it a treat for us, right? That's essentially what we want to do at the end of the program. I'm sure all you guys are with me, right? LRDI, like I always say, can be an Achilles heel for students in the examination, but if approached in the right method, right? And believe me on this, if approached in the right method, this is something I've been doing consistently over the past few years, and every time before the exam, I want to review the kind of caselets that I do in the classes, and only with that preparation I go to an exam to still enable me to get round about that 99.5 percentile year after year in LRDI, right? Or at least attempt questions so as to get that. I generally don't take up the exam to get those marks. I normally leave it blank or otherwise, right? But the idea is, have I done enough caselets? Yes, that's enough caselets to get fetch me 99.5, right? So let's answer of the questions here. Pretty simple otherwise. That means you'll notice this data is missing and this data is missing. Nothing can be done. We cannot assume data until and unless mentioned in the questions. So let's see the 11th one. Which of the following pair arrived first? So who arrived first? That's something that we don't know. We have no clarity. We cannot say, hey, listen, you know what? I think, Akshay came first because alphabetically Akshay's name comes before everybody else, and Avinash came after. We cannot do that, right? Its answer is indeterminable, right? That's the first one. The next one is here, that who is married to Sonal and Shobha respectively. So who is married to Sonal and Shobha? Amit is married to Sonal, and Ashish is married to Shobha. So Amit is married to Sonal and Ashish is married to Shobha. That's an easy question once you know. So the good thing about data arrangement, your general data arrangement, is once you have solved it, right? The questions will barely take some time, right? Probably it might just be a direct question thereafter, or even if there is some extra data to be thought of, it's not too much, right? So the last question of this caselet, which of the following pair arrived second, right? So we know Amit and Sonal arrived second. That's a pretty simple caselet. Like I said, very easy, right? A little bit on grid. This is quite important in cases because you might end up saving at least 15, 20, 30 seconds or a minute easily, because otherwise you're writing a lot of details outside the table, right? Outside the table. That's why the pivotal column can make sense. There's another thing that I would like to tell you. The pivotal column sometimes may not, if there is a choice in pivotal column, sometimes I would choose a pivotal column which is ordered. What do I mean by ordered? If I have days of the week like Monday, Tuesday, Wednesday, Thursday, it is better to make this as a pivotal column. That means the first column, and then start working right on other things. It will help us in organizing the data in a little more better way, right? That's the entire idea of putting it in an ordered format, right? That's the entire story here. Let's go to the next caselet. I hope you guys are with me, right? If okay, let's say okay. Okay, is that fine? Is that good? Right? I hope you guys are having fun. Right? Let's move to the next question. right? We'll get up to move to the next type of question or caselet on LR and DI. Very nice, very simple, cheesy question, but based on numbers, I'll give you 30 seconds to think on this, and then we will review the question. 30 seconds, right? Your time is already started. Please read the question. So almost there, almost going past the 30 seconds. Okay, let's take another 5-10 seconds. Probably you can finish off reading those point number 3 or 4 or 5 which you've not read. Okay, that's like 40 plus seconds. I've given you about 45 seconds till now. Good. Let's see what we can do with this caselet. Easy one, numerical. Numerical is something that you guys should be looking at solving, right? Numerical LR is something, it's a must. It's a must solve because your answers, you will surely get it. It is just numbers. It's going to be damn easy. It is going to be the easiest thing, right? Okay, it's going to be easy. It's something that you guys must understand. If there is numerical type, more often than not, it is easy, right? It's going to be easy because you can plug in the values, right? So let's look at the caselet. There are these 5 guys. Their names are J, K, L, M, and N. They collected stamps. The total stamps collected by the 5 of them is 100. None of them collected less than 10. So minimum, J is 10, K is 10, L is 10, M is 10, and N is 10. Minimum, that's not that number because the total happens to be 100. I cannot say 10, 10, 10 each. No two among them had collected the same number. That means, so, okay, fine. If this is 10, this would be minimum 11, 12, 13, 14 in no particular order. Guys, please understand, no particular order. It's not necessarily 10, 11, 12, 13, 14, but I'm just saying, even if it were 10, 11, 12, 13, 14, that would have not been with any order. We don't know who is, whether it is 10, 11, because the total has to be 100 in the first case, right? Now let's start with the caselet. Pretty simple. Each of them had 10, minimum 10. They should be 10 or more than 10. All of them had different and the total was 100. Now the clues are going to be very important to solve. Most of this data arrangement, numerical type, seating arrangement, alphabetical type, circular arrangement, most of it, right, would be solved with the data, right? Though there is some element of math like I mentioned, but the clues, the additional clues, these are the clues that we are talking about, right? The add on info, that's really important. That's critical in solving the caselets. So don't assume when you're reading these caselets, by the time you read that, you're okay, fine, I have so much data, it's bad. The more the data, the good. That means there is a higher chance that it's going to be easy. The less the data, there's a chance that it's going to be highly logical. And that's when you need to start thinking. But there's no such golden rule key, if there are more add-on info or, data, right, there are more clues, that question has to be tough. It could be both ways, less clues tough, more clues tough, but as a rule of thumb, I see more clues as a little more easier, less clues as a little more logical, right? So let's begin. J collected the same stamps as K plus L. That's the first clue. J collected the same stamps as K plus L, which means, can I say if we add J plus K plus L, right, this should be a multiple of 2. Now, why this multiple of 2 we are talking? Because K plus L and J are the same number. That means, if let's assume this is 13 K plus L, which cannot be, it should minimum be like 21 or something. Let's say, okay, let's say it's 21, right? If K plus L is 21, J also has to be 21. 21 plus 21, that is 42. In case it's a odd number here and this combined together is an odd number here and J alone is an odd number, together they will become an even number. Even if we have K plus L as an even number, right, J has to be an even number. Even plus even is twice the number in question. So it is eventually going to be a multiple of It's eventually going to be a multiple of 2, right? Are we okay? So very simple data. We're using the math part here, right? So we're talking of these guys, J, K, L, M, N, total of 100, right? We know J is equal to K plus L. We just understood that K plus L, if it is an odd number, J also is to be an odd number. That means J plus K plus L is even. What if we had K plus L is an even number? Even then J would be an even number. Even plus even, we understand. Even plus even is necessarily even. Odd plus odd is also even. So it shouldn't matter. Yeah, one small thing, guys. Please don't question me on this. I'm sure no one is questioning me, but some of you I know will come up with these cheesy questions just to get me, a little uncomfortable. K, why isn't even plus even 2 times even number? Okay, so that's just out of context. Just letting you know how sometimes people can make it fun in classes, but otherwise, like I keep saying, right? Let's see how to solve this, and after that we'll discuss a little more on questions like this, right? So J collected the same as K plus L. L collected 3 more than the cube of an integer. Now let's look at the values of L. What could be the values of L, right? If you're talking of a cube of a number could be 1. Cube of a number is 8. Cube, that's 2 cube. We have 3 cube 27 and 4 cube 64. By chance, L is 3 more. 64 plus 3, L would become 67. But if L alone is 67, J has to be more than 67. The total number of stamps collected has to be 100. This number, this answer, if L is 67, right, 67 plus J itself is exceeding 100. Now that's a big worry for us because it cannot exceed 100, which means 64 is negated. What if I choose, what if we choose that, n is 1? If n is 1, L would become 4. Is that a problem? Right, 4 is okay, right? We don't have a problem with that thing. But the problem is if this is 4, right? It is not a number which is greater than or equal to 10. The minimum value of each of the person, the number of stamps collected by each of the person, like I said, is going to be at least 10, right? That means we are letting only two cases, 8 and 27. Assuming we choose it to be 8, right? That is n cube. L value would become 11. And assuming we took n cube as 27, L value would become 30. Now, if you look at each of these cases, right? If I take L value as 30, K value has to be minimum more than 10, right? That means 10 or more than 10, which means even if it is 10, then J value would become 10 plus 30, which is 40. That means this plus this plus this will become 40 plus 40 because we have J plus K plus L. 40 plus 10 plus 30, which is equal to 80, which means that M and N both have to be 10 and 10, which is incorrect because no two of them collected the same number. That means all this is not important. All this was just a waste of time. Just a waste of time. We easily identified, by now what is the value that we are looking at. Most of you would have also got it much earlier, that we identified that L has to be 3 more than the cube of an integer, which means here it would become, right, L would have become 11. There's no other choice. We just checked sometime back, 27 plus 3, 30. If we write L is equal to 30, we still could not assign a value of M and N. So we know for sure L is 30, and we know, J is equal to K plus L. L is not 30, sorry, L is 11, right? That's something that we understood. The number collected by J was the square of an integer. So we know L was 11, K is some number, and J is square of an integer. Square of an integer. So we cannot take 1 square and 2 square and 3 square. Why not? Why not? We cannot take these values because they're all a digit. We need a minimum of 10, right? So we could look at 16, we could look at 25, we could look at 36, we could look at 49. The inherent problem with looking at 16 is if J becomes 16, K will become 5, and we know the number of stamps collected by each has to be, at least 10. So we cannot fit that. What if we take J as 49? If J is 49, K plus L. We know this statement, if J is 49, K plus L is also 49, which means M and N both should be 1 and 1 or 0 something, which is not allowed. There has to be a minimum number of stamps collected by everybody. That's equal to 10 or somewhere around that mark, right? Okay, we'll go to the next statement. The number collected by K was either the square or the cube of an integer. So K again is square or cube of an integer. Okay, so we have two values, one 25 and one 36. Guys, these are the values for J. These are the values of J. If J is 25, we already know L is 11. Then what would be the value of K? K would become 14, right? Are we okay on the same page? But we know that K was either the square or cube of an integer. No integer cube is equal to 14, and no integer cube, right, or no integer square is also equal to 14. That means we can skip a beat and say, hey, listen, this answer is not 25, which simply means J has to become 36. And in turn, K became 25. Excuse me for that, right? K became 25. And the last statement, the stamps collected by M and N, there are 28. On to each of these parts, but there are 4 parts. So 4 into 4, that makes it 16, and 3 into 4, that makes it 12. Are we okay? That's a very easy caselet to just start. You'll understand. We're just starting this class with some amount of thinking behind LR. Very simple, but you saw we can solve this caselet just by taking one by one the statements. And as and when the statement comes, you saw that I'm only working on that data alone. I didn't, though we might know the data in the next question, the aim was not to do that exactly. The aim was to take step by step, because in the exam hall, you're pretty much going to read step by step. You're not going to haphazardly read the last statement like you might do in questions on RC, right? That you read the last statement and then solve, read the first paragraph and then try to solve the question. That's not what you'll do in LRDI. Please refrain from doing that in LRDI, because LRDI is more process oriented. Guys, I'm sure you guys will get into B school. You'll study this book name called Fifth Discipline by Peter and Singh. Please read it. You'll understand how systems perspective can help. I'm not talking of LRDI. It will help you in life as well, right? Like I always keep saying, okay, there's a distinct advantage of the online model, but I'll talk about that in a while. Let's finish off the question 14, 15, 16, 17 and 18. The number of stamps collected by J was, that's simple data. The number of stamps collected by J, what was it? That was 36, right? The next data, the number of stamps collected by K, right? So what is the number of stamps collected by K? That's simple. 25. Someone would remember at the back of their head. Please put your answer in the chat window, right? Number of stamps collected by how many in the group with prime numbers. You should notice, right? I think we can identify with only one prime number, which being L, and L is equal to 11. So that's a simple question here. Number of prime numbers, number of prime number stamps. Okay, we didn't do this question. Let's finish the prime number. With prime number only 1. Let's come back to the question 16. 16 says the difference in the number of stamps collected by L and M. What is the difference? So we know that L collected 11 and M collected 20. L and M, right? M collected 16. Sorry, that's 16 and L collected 11. The 16 and 11, the difference is what they're asking. That is an easy number. That's 5. And the last question in this caselet that we've left, the number of stamps collected by which pair among the following together add up the cube of an integer? Which two will add up to the cube of an integer? So looking just by observation, you'll notice 16 plus 11 is equal to 27, right? 16 plus 11, who are the persons in command that we're talking about? 16 and 11. 16 happens to be M and 11 happens to be L. So M plus L are the people who are collecting, right, the total number of stamps, which is a cube of an integer, M plus L, right? Very simple case fluid. Yeah. Coming back, I say, right? I kept saying that, it's pretty easy. It's pretty nice to be in the online sphere. What's the advantage of an online sphere? Guys, you must understand that in a classroom environment, this class would either go way faster or way slower, right? Now, why way faster? It's way faster because, in a classroom, what normally happens is I might want to identify with one or two or maybe five out of the given 50, 60 people in the class, right? They're the ones who are giving answers. I get influence, there's a bias, etc., etc. It could get really slow because, maybe because I'm initially starting off to talk fast, right? Trying to, make someone happy in the class, the students who pretty much prepared and came for the sheet. They want it really fast, right? So what about them, right? I might start going fast in the beginning, but because I went fast in the beginning, many did not understand. So I'll have to slacken my pace, not marginally but considerably, to make it work, right? So there's a lot of time loss in all of this. Second thing, in the online model, the online class, the live classes, you can always get back to the video, and you just have to see the video again. That is not the entire video, just a part of the video. Whereas in the offline model, if you don't understand something, forget LR only, it could be any other topic, you might have to repeat the entire class. Now understand the time loss. Forget the time loss, the productivity loss to the entire country that we are talking about, right? We are talking of, thousands of students, right, who will be going through this class. For them, the entire country productivity loss is something we are talking about. Anyway, there's a few more questions in this particular sheet. Let's run down through them. I'm sure you guys are all okay.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free, AMC.